Welcome to my YouTube channel Cognara. I'm Michael, your science and technology educator. Today, we are going to explore a question. It quietly sits at the edge of modern science and philosophy. It is a question that sounds like science fiction at first. But the longer you think about it, the more serious it begins to feel. What if the universe we experience every day is not base reality at all? What if it is something closer to a simulation? At first, this idea feels strange. It feels like something taken from a movie or a video game. But it did not begin that way. It came from real scientists. From computer engineers. From physicists who noticed something unusual about how reality behaves when we look closely enough. It also gained attention when Elon Musk publicly said something surprising. He said that the odds of us living in a simulated universe might be far higher than most people imagine. To understand why anyone would even consider this idea, we first need to look at how fast technology is advancing. Just 50 years ago, computers filled entire rooms. They could barely perform simple calculations. Today, we carry phones in our pockets. They can render 3D worlds. They can simulate physics. They can generate realistic human faces and voices. If technology continues improving at even a modest pace, then something interesting begins to happen. It becomes possible to imagine future civilizations. Civilizations capable of simulating entire worlds. Worlds with conscious beings inside them. From that perspective, a strange probability argument appears. If advanced civilizations can run millions of simulated universes, but only a few base realities exist, then statistically, most conscious minds would be living inside simulations. Not in the original universe. That idea makes people uncomfortable. Not because it sounds ridiculous, but because it sounds logically consistent. Elon Musk once explained this idea using video games. He pointed out that games went from simple dots on a screen to fully immersive digital worlds in just a few decades. If you extend that timeline forward by thousands or millions of years, then the chance that we are living in the original physical reality becomes extremely small. But philosophy and probability are not the only reasons people take this idea seriously. Physics itself has begun revealing details about reality that feel oddly digital in nature. When scientists study matter at the smallest possible scales, they find that energy and space are not smooth and continuous. Instead, they appear to come in tiny discrete units. Almost like pixels on a screen. There is a smallest measurable length in the universe. It is called the Planck length. Below that, space itself loses meaning. There is also a smallest measurable unit of time. It is called the Planck time. These limits are not just technical problems with our instruments. They seem to be built into the structure of reality itself. As if the universe has a fundamental resolution. Some physicists have also noticed something else. The laws of physics appear strangely optimized. The constants that govern forces, particles, and cosmic expansion are balanced with extraordinary precision. If they were altered even slightly, stars would not form. Chemistry would not work. Life would never emerge. This fine-tuning has puzzled scientists for decades. While there are natural explanations, some people see this as another hint that reality might be configured, rather than accidental. Then there is quantum mechanics. At the smallest scales, particles do not behave like tiny solid objects. They behave like probabilities. They only become definite when they are observed or measured. This is known as the observer effect. Some thinkers compare this to a video game that only renders detail when a player looks directly at it. Even more strangely, particles that are separated by vast distances can remain instantly connected. This is called quantum entanglement. Changes to one particle appear to affect the other instantly. Even faster than light could travel between them. Einstein once called this spooky action at a distance, because it violates our everyday understanding of space and causality. Some researchers have noticed an interesting parallel here. In a simulation, distant parts of a virtual world can remain perfectly synchronized, because they are managed by the same underlying code. This is not proof of anything, but it is a resemblance that makes people pause. Another clue often discussed is the mathematical nature of the universe. At its core, reality appears to be governed entirely by equations. Every particle, every force, every interaction, all of them can be described using mathematics. Some physicists have even suggested that the universe is not just described by math. They suggest that the universe is math, operating like an enormous computational process. This connects to another idea, that reality may be running on something similar to information processing. Black hole physics, for example, suggests that information is never truly destroyed. It is only transformed. Some scientists now believe that information may be more fundamental than matter or energy. If reality is fundamentally informational, then the idea of a cosmic simulation stops sounding absurd. It starts sounding like a technical hypothesis, even if it remains unproven. There are also reports of what people call glitches in reality. These include rare physical anomalies, unexplained coincidences, strange perception distortions. Most of these can be explained through psychology, probability, or incomplete data. But they continue to fuel curiosity. More formally, physicists have searched for limits to how much information the universe can store and process. Surprisingly, there appears to be a maximum data density and a maximum computational speed. Both are set by physical laws. These limits resemble constraints you would expect in a computational environment, not an infinite physical one. Still, it is important to be honest. There is no direct evidence that we are living in a simulation. There is no observable edge of the universe where code becomes visible. There is no cosmic server room humming behind the stars. All of the clues we discuss are patterns and analogies, not proof. Many scientists who take the idea seriously remain cautious. They point out that just because something resembles a simulation does not mean it is one. Nature often produces structures that look designed or optimized, even when they are not. There is also a deeper question. If we were living in a simulation, would anything actually change? Would love suddenly become fake? Would curiosity lose its meaning? Would creativity and suffering stop being real? Most philosophers argue the opposite. They say our experiences would remain real and meaningful, regardless of what reality is made of underneath. In a strange way, the simulation hypothesis does not diminish human existence. It may even deepen it. It reminds us that reality is far more mysterious than our everyday assumptions allow. It reminds us that we are still beginners in understanding the true nature of the universe. Whether we are living in base reality or a simulated one, the stars still shine. Gravity still holds us to the Earth. Our choices still shape our lives. The same curiosity that led us to ask this question is the same curiosity that will one day bring us closer to an answer. For now, this idea remains a mirror held up to our technological future. As we build more advanced simulations ourselves, we may slowly discover whether we are following a path that has already been walked by someone else, somewhere beyond our visible universe. And perhaps the most honest conclusion is this: the simulation hypothesis is not about escaping reality. It is about understanding how deep reality truly goes, and how little of it we may have seen so far. Thank you for exploring this question with me today. If you enjoy calm, thoughtful journeys into science and technology, then you are in the right place here at Cognara.